which we wanted to use for research. But as you can imagine, since the data came from this source, you could be pretty sure that it was not representative. So in other words, we're back to that scenario here, the one we described earlier, where our data came from a convenient sample, right? But we wanted to make results that were generalizable. So I needed to understand that point. That's why I keep repeating myself like a broken bell, because that is the crux of the whole lecture. The whole lecture is, when do we use, in this specifically, calibration weight? We use calibration weight when somehow your results are non-probability, but you want to make them somewhat generalizable, at least to some extent. Again, okay, so I promise that's the last time I'm going to repeat that. So to put what weighting does, I want to compare two constructs in epidemiology that are very similar. So you can okay, that's a completely different off tangential issue. So the first concept is the issue of standardization, right? I want to talk about two concepts here: standardization and weight. They are similar, but very different a bit. In standardization, I have two populations, population 1 and population 2, and I want to compare those two populations. But I can't compare them, at least not directly, because they are so different. Look at these populations, right? Look at the shape. We're just looking at this from perspective of an analogy now. The shape of this guy and the shape of this guy are very different. This guy is a square block. This guy is a circular shape, or I don't even know what that's, an amorphous shape. There's no shape to it. It's lumpless. So it's hard for me to compare the two directly because they are so different. Now, think of it as how that applies to a population, right? You could have two populations that are very different, and you want to compare them. Let's say you have population A is a population that has a lot of young people, and population B is a population that has a lot of old people. Obviously, they're not the same, they're not similar. So you cannot directly compare them. If you were to say, to ask those two populations, on a scale of 1 to 10, how much do you love playing soccer? Of course, the results are going to be different because they are very different ages, right? So the question then becomes, how do we compare outcomes between population 1 and population 2, given they are so different? In standardization, what we do is that we take a reference population, another population, and we force those two populations to be like the reference population. And then we can compare populations 1 and populations 2. This is called standardization. And I explain standardization because a lot of people always ask me, so what's the difference between standardization and weighting? All right, so we know what standardization is. At least we have an idea of what it's supposed to do. Now, let's talk about weight. With weight, it's a little bit different. This is our population here with weight, right? This is our sample. So think back to the cycle of inference. We have a population, and then we have a sample. So here, this is our sample. This is what it looks like. Now, this is our population, and this is what it looks like. Now, you see, we have a problem here. For that cycle of inference to work, the sample and the population must look alike, right? They must look similar. They don't have to be identical, but they have to look similar. These two things don't look similar at all. This one is shaped like this. This one is shaped like this. So the question is, how then can we, in good faith, make that cycle of inference where we get inferences from the sample to be generalizable to the population? Now, that's where weights come in. Weighting is a way of forcing our sample to look like the target population. So we take this clay and we somehow force it to look like this guy. Now, you can now see that these two guys, they don't look identical, but at least they look similar. So now we can go ahead and compare these two things. So that's what weights do. Weighting is a statistical process of, we take this sample that doesn't look anything like the parent population and we force it to look like the parent population so that we can make comparisons, or we can make inferences from the sample to the parent population. I'm going to stop there and see if you guys have any questions before, to make sure you're not lost. Any question? Multi-stage sampling is a probability sample. Any other questions? All right, none. A little recap on standardization. Okay. So let's go back to standardization. So let's say we're trying to ask, what is the death rate between population A and population B? Population A is very young people. Population B is very old people. So the question is, what is the death rate between those two? Now the obvious answer is, why are you trying to compare those two groups? They're not, of course, you'd expect that the older population will have a higher death rate. So that is not even an interesting question, right? So if you are looking at the, because the two are not directly comparable. Because if I'm trying to look at death from all causes, not just death from aging related factors, my question is, what is all-cause mortality, and how does that compare between populations A and population B? So I'm not necessarily interested in deaths that occur when you grow old and then you develop some condition that is related to aging and you die. Of course, we'll expect that to be higher in the second population that is older. I'm interested in all-cause mortality, but I have a problem, right? I cannot compare those two groups directly because they are very different. So what do I do? I can now say, all right, I'm going to force these two populations. Both of them are going to look like this third population. So we're going to say, if population 1 were like this reference population, then the death rate will be so and so, right? And then we are also going to say, if population 2 were like this reference population, then its death rate will be so and so. So because I have now forced both of them to adopt the characteristics of this external population, that allows me to make direct comparisons, because population 1 is no longer population 1. It's like population 1 if it were the reference population. We call that a pseudo population. It's called pseudo because it doesn't exist. We just made it up. I'm not going into the nuances of it. I just want you to understand, at least on an intellectual level, what we're doing behind the scenes when we write that code. When we talk about a pseudo population, I need to just understand in very simple terms, no complication or nothing fancy. With standardization, we're just taking these two populations and forcing them to look like a reference population and then comparing them, because now they both look like a reference population. What conditions are to be met before using non-probability for generalization? You have to weight the data. So you have to, first of all, check that how does this population look relative to the question, by the way, was what conditions are to be met before using non-probability for generalization? So the answer is, if you're trying to generalize, you should at least try to you should try and sample the right way. We don't want medicine after death. Calibration weight is just medicine after death. So you should design your study appropriately so that you don't even have to worry about this kind of issues. We are talking about a scenario where you have no choice. It is what it is. That's what you met. So this is not to encourage bad study designs. You should design your study the right way and sample the right way. All right, so I'll just go through this, and then we'll look at some of the practical applications. And if you still have questions, we can then take them. All right. So again, with weight, this is our population here. This is to explain the same thing we explained in the previous slides. Here, we've taken from this parent population, we've taken a sample. Now you can see that the distribution of these colors, blue, gray, and orange, is exactly the same here as it is here. Of course, this is a bigger cycle because it's a parent, and this is smaller because it is a sample. But apart from the size, you can see that these two are exactly the same. Now, this is what we want ideally, right? And this happened because we drew a random sample. And since the sample was random, it allowed the characteristics of a population here to be retained in the sample. So in this kind of scenario, we don't need weight. Now here is where we have a biased sample. You can see that blue is more than half here, but it's less than half here. So this sample does not look like the parent population. So we cannot make that cycle of inference. We cannot make inferences from a sample back to the parent population. Why? Because the child does not look like the parent. So the parent will say, no, I can't adopt you. You cannot make inferences from you to me because we don't look alike. So what do we have to do? Well, we have to use weight. Weight will force this sample to now look like the parent population, so that now we can now make inferences from this back to the parents. That is all we're trying to achieve with weight. I hope that is clear. So again, don't worry about the technical nuances or the scientific math behind it. Just understand it from a simple pictorial form of why weights are needed and what they achieve. It's all about, we want to force the sample to now look like the parent population so that we can go ahead and make some kind of inferences. So that is what we're trying to achieve. So why do we wait? Your sampling technique was not based on a specific sampling frame. So, you got data from the internet or a web survey, like the Health 24 survey we used in our study, where individuals self-select, like a convenience sample or a volunteer sample. You have to wait. Now, there's another type of waiting, which we're not going to focus on so much today, which is when you oversample, right? But we're just going to focus, for today, we're just going to focus on this first part, because the last lecture we had, we focused more on the design weight. So now what happens if your data has weight, but you ignore them? Let's discuss that, and then we'll go on to a practical application of what we're talking about so that you might have some context. So let's look at two scenarios, the green scenario and the red scenario. The green scenario is they were weight and we accounted for them in our analysis. So here we're trying to find the average. So when they are weight and you account for them, the average is simply 1 times this plus 2 times the weight plus 3 times its weight plus 4 times its weight plus 5 times its weight, all divided by the sum of the weights. So the result here, we see that our average is 4.7. Now, what happens when they are weight and we ignore them? When you ignore weight, you are then saying that everybody in the data set has a weight of 1. That is what happens when you ignore weight. You are assigning automatically, whether you realize it or not, you are automatically giving everybody a weight of 1. So when analyses are not weighted, that's an indirect way of saying that is that everybody has a weight of 1, right? So unweighted analysis means everybody has a weight of 1. At least that's what the analysis assumes. So here you are saying 1 times 1 plus 2 times 1 plus 3 times 1 plus 4 times 1 plus 5 times 1, all divided by the sum of the weight, right? And that gives you 3.0. So here, see, when the analysis was weighted, the answer was 4.7. When the analysis was not, or when we ignored the weight, the result is 3.0. Now, 4.7, the last time I checked, is not the same thing as 3.0. So that means that your results are not valid. So this is what happens when there are weights, but you ignore them. So please don't ignore the weight. So, like I said, 2 types of weight, design weights and non-response weights. We'll talk more about them. With these slides, we talked about them extensively the last lecture on weights, so I'm not going to dwell on them so much for the sake of time. Now, when you are creating weight, you need to select the variables you are trying to weigh on, right? And so the idea is that your variable or your data set has certain characteristics in it that differ from the population. So the first step is you want to take a tabulation of some key variables like demographics, age, sex, race, education. You want to compare those variables in your data set and you want to see how they compare to your overall population. So if my data set is, for example, the South African population, I want to see what percentage of people in my data set are male and female, and how does that compare to the South African population overall based on, for example, census data. If those two are different, then that means I have to weigh the data, right? So that's how you select the variables that you're going to weigh on. They are like demographic variables, and you have to, then make sure that you have information for those variables in the census too. Now, there are some things that might happen when you are trying to weigh your data. The ideal scenario is that the categories for your variable are the exact same categories in the census data or wherever you are using as a reference population. So here, for example, the ideal scenario is that in my data set, I'm trying to weight on gender, and I have male and female as the categories. And in the census data, I also have male and female. The categories you have that you're trying to weigh must be the exact categories that you have in the reference population, in this case, the census. So this is an ideal scenario. Now, it's not every time you have an ideal scenario, so you have to know how to manage it. Now, you don't have to know all of these things you don't have to do this manually. The platform, on the Chisquares platform, all of this is completely automated for you. This lecture is just to give you an idea of what is going on behind the platform so that you know what's going on. Now, this is ideal scenario. You're trying to to weight on, let's say, gender, and the gender categories is exactly what you have in the data set versus what you have in the census. Now, let's look at other scenarios that may not be ideal. Here we have a second scenario, right? We have, in our data set, we have three categories. We have male and female, but we have missing values. Of course, the census doesn't have missing values. The census has male and female, but our data set has male, female, and missing. Remember that the rule is the categories you have in your data set must be exact same categories as you have in the census or whatever you're using as your reference population. Again, you cannot weight your data if you don't have external information. There's some information you are bringing externally to force the sample to look like the parent. That means that you have information about the parent. You're trying to force the sample to adopt the characteristics of a parent population. So the moral of the story is, to weight data, you must have information on each of those variables you want to weigh on. So if I'm trying to weigh on gender, that means I have data on gender. I know the distribution of gender in my target population. If I don't know that, then I can't weigh the data. So here we have a little problem, because in our data set, we have three categories: male, female, and missing. And those categories must be exactly what you have in your reference population, in this case, the census. So what do we do here? Well, we can absorb these missing values and assign its values at random to the male and female categories, so that we end up something like this. So instead of having male, female, and missing, we write what we're doing is that we take the three here and assign them at random to male and female, so that male now becomes, there were 23 people initially, but now by random we added 2 to it, so it's now 25, and female is now 33 because we added 1 more to this at random. It has to be at random. So now we can see that the categories in our data set is now exactly what we have with the census. Now we can then proceed to weigh on gender, right? So that is what must happen. The two categories must be, no, you don't remove it. You don't have to do anything. You just upload the data. This lecture is just trying to, somebody was asking, do they have to do this manually? No, you don't. The platform automatically does all of these things. The platform, you specify the variables you want to weigh the data on. Every single thing is done for you automatically, obviously. But you also need to understand what is going on. So that's why we're trying to explain to you what happens in the background. All righty. So that is scenario 2, and that's how we can address it. Moving on to the next scenario. In scenario 3, we have something similar. We have male, female, and other in our data set, but the census only has male and female. So we're in a fix here because like the categories must be identical for you to weight them. So what are the options? Well, option one is to reassign other at random into male and female. Option two is we might say, okay, we know this other, right? We might say, okay, it's female / other. Maybe the other category is very similar to one of those two groups, so we can just combine that other with one of those categories. Or option three is that we can go and look for another source of information that categorize gender in the census or wherever that information is coming from as male, female, or other. One way or the other, something has to give, right? So the two groups, the two categories must be identical before you can weigh. So here's scenario number 4. Here we have male, female, transgender, and agender as our categories in the data set. But in the census, we have only male, female, and other. So what do we do here? We can collapse transgender and agender into one group, and we can call it other. So that now these two categories are identical, and we can proceed with our weighting. All right. I'm going to stop here. Answer any questions you have before we go on to a more applied form of this class so that you can understand what in the world we're talking about. I can understand if you are lost. But we're going to look at a paper that did all of those things, and I will walk you through the process so you can see how that works out. So let me take questions for now.
Okay. So I'm just trying to check the last one. Is it possible to even get a sample that will look exactly like the parent population?
No, it doesn't have to look exactly. Remember, it just has to look, it has to have similar characteristics.
Can I standardize 4 populations that were studied for a different duration for a similar attitude?
Forget about standardization. This last on weighting. Standardization is when you have 2 different populations you want to compare. If I want to compare the United States and Nigeria, 2 different populations on an outcome, then I standardize them first so that I can now make direct comparisons. So, but for the sake of analyzing, if you're just analyzing one population, standardization does not apply because for you to standardize, that means you have 2 separate populations you're trying to compare, and you need to standardize both of them so that they look alike before you can compare. So that does not apply in that context at all.
For 4 populations.
Sorry?
4 populations.
Yeah, you can standardize any number of populations. I mean, 2 or more.
Okay. In a population like Nigeria, how do you weight it so that it can reflect the real population of Nigeria so that you can carry on your research?
All right, to be continued. That's what the second part of the lecture is supposed to address. So hang in there.
Is pseudopopulation the same with assumption population?
With a what?
Assumption population.
Yeah, well, they're both saying the same thing. Pseudopopulation is a more technical term. We're calling the pseudopopulation because that does not exist. We just created it from math, from statistics. It does not exist in the real world. The only reason why we created it is so that we can compare something.
Okay. A little info on capture, recapture, please.
Okay, and would since that's not the direct focus of this class, we'll answer it at the end if we have enough time. But let's just focus on weight issues. But I'll answer that at the end.
Yeah, that was actually the last. Oh, okay.
No, there are some questions now here.
Okay. Can we weight variables before sampling?
Can you weight variables before sampling? No, you can't. Remember,
Okay.
you have to sample, collect data from the survey, and then you weigh. If you don't have information in the data set, you can't possibly weigh.
Does that imply that weighting occurs due to poor study design?
That's a good question. Yes and no. Sometimes it could be that, like in this case of the Health 24 survey, right? We didn't collect the data. This company had the data, and then they reached out and said, "Oh, we have, by the way, we have data for South Africa overall, right?" And we're like, "Oh, really? We how many people on your data set? Like 18,000 people." Like, "Oh, wow, that's a lot of people. How was it sampled?" Like, "Oh, people just came to our website and answered." We're like, we have a problem. Your sample is not representative. But don't worry, we will still get the data and use it. We will weight the data. That had nothing to do with us. That's how we met the data. Now, sometimes despite the best design you do, participants may still not respond. So let's say you did a random sample and you administered your survey, and all the people of a particular demographic, or some groups just refuse to answer your question for whatever reason. You will still end up with a biased sample. So sometimes it's not about you, it's about the participants. And sometimes it's just because of bad design, obviously. But you have very little control over how people are going to respond to you. In fact, you have no control. Okay, maybe you have some control. You can give them incentives and stuff. But essentially, my point is that people can choose whether or not to participate in your survey. And if there's a systematic difference between some certain groups, then you end up with a biased sample. Then you have to worry about weight. So it's not always a function of bad design. It could just be that people, the mode of administration, let's say if you did it on the internet, not everybody has access to the internet, right? The people who have access to the internet may be people who are rich or people who are young. That means that your survey has systematically excluded people who are older or people who don't have telephones or who don't have the internet. Now, your sample no longer looks like the parent population because it's selective. It's just a special group of people who are in your survey. So whenever you have any scenario that creates a special group, people who are in your survey are a special group, not everybody, then you have to worry about weighting. I hope that makes sense.
Thank you. If one has to analyze data across all 9 provinces in South Africa, which are not equal in terms of size of population and their skin color?
Okay, that's a good question. So, but the question is incomplete. So yes. If how then do you assess whether the sample is representative?
Oh, how do you weight it?
Okay.
Oh, so how do you weight it? You completed it later. How do you weight it?
Okay, how do you weight it? We will give an example. So don't worry, that's the second part of the lecture. We're going to give an example on that.
This random assignment at random of male and female to fill missing values to mimic the reference population. Does the outcome or result look exactly like what other programming language does? For example, Python or R? Thank you.
So if you weight something twice, they are not going to look alike. Because remember, assignment to groups is at random. And if it's at random, it means that if it repeats the again, it's not going to be the same, even if you use the same software, because you are assigning at random. Now, what we use on our platform is we use programming languages too, right? So what in principle is the same thing that's been done. It's just that you don't have to do it manually. I hope that's clear. I'm reading a question that says, can you repeat what attributes can drive us to weight our sample? That's a good question. So you start on demographic variables like age, sex, race, social demographic variables. That's what we typically use. So in some of our large surveys, we use up to 15 to 20 variables. Think of things like income, education, race, ethnicity, where you live, whether it's a rural or urban area, where your marital status, whether you have children, whether your religion, things like that. These are the kind of variables we look at. So we're looking at 2 things. We're looking at what is the distribution in our sample and what is the distribution in the target population nationally. So in the case of South Africa, we're saying in our sample, what percentage is male and female in our sample? And when we look at the national sample or the national population, what percentage is male and female respectively? If those 2 things are not similar, then we know that we had some selection bias here. So we have to account for gender in our weighting. Then we'll move to the next variable and say, okay, race ethnicity. What is the percentage of white, blacks, Hispanics in our sample? And what is the percentage in the national sample? If those two things are not similar, they don't have to be identical, but they should be similar. If they're not, we say, we have selection bias on this. And that's how you go for all the variables, right? Then you can now say, okay, these are the variables that we need to account for in our weight. And then you weight on those variables. So that's a simplified roadmap of what goes on. All right, let's go on and see.
Can the outcome of weighting lead to manuscript rejection?
Well, rejection or non-rejection depends on what your intent is. Remember, it all starts with your intent. If your intent is not to create, and that's a very, very important point I want to really emphasize, it is about your intent. If your intent is not to create generalizable knowledge, then you don't even have to be worrying about weighting. So let me go back to that original slide, because I really want to emphasize that. I can't emphasize it enough. It is your intent. Do you have an intention to create generalizable knowledge? Now, unfortunately, the only person who can know your intent is you. Nobody can know your intent except you. So you are the one who has to decide whether you are trying to create knowledge that is generalizable or non-generalizable. But this is the litmus test. Is there an intent to create generalizable knowledge? Now, that is what will determine whether you weight the data or you don't weight the data. You can say, I do not care about, this study was not about generalizability. We're just interested in what the participants had to say and not about generalizing what they said to the whole country. And that is perfectly fine too. Scientific publishing is all about how you argue your case. There's no right or wrong answer. We only have a problem when you tell me that the results are generalizable, but I can see that they're not. That's when I have a problem with you. But if you already came out clean and told me that, no, I had zero interest in generalizing, then that's fine. You know, nobody's going to force you to say, to define that your intent is this way when it was that way. But you have to figure out what your intent is, and your methodology has to align with that intention. The problem is when your intention is going one way and your methodology is going the other way, that's when we have a problem. Okay. So we usually weight based. Sorry, go ahead.
Sorry. No, sorry. Continue.
No, you had a question to ask. Please go ahead.
Can you repeat what attributes can drive us to weight our sample?
Social demographic variables, and you have to start comparing within your sample versus the target population, whether it's a national sample or the country data or census, for example. So social demographic variables like age, sex, race, income, number of children, religion, those are all important variables. Essentially, we're trying to say, was there bias in how you selected your sample? And that bias will be reflected in various demographic variables.
Can we say that weighting requires that a secondary data, published in brackets, must have existed and related to your intended study area?
Exactly. You cannot weight if you don't have external data, right? So if you told me you wanted to weight the data, and I asked you, so where are you getting your population marginals from? Where are you getting the source data from? And you are staring at me as if you've never heard of that ever in your life. I'm like, so how do you want to weight the data? Like, is it with a magic wand? You have to, if you want to weight the data, you must have data, external data that aligns with the variables in your data set, right? So that is the only, it's like it's exact same way when you want to weigh yourself. You have to bring a weighing scales and stand on that scale. It's the same thing. If you want to weigh data, you must bring in that scale, which is the population characteristics from the census. That is what we're going to use to weigh the data. So those two things must go hand in hand. I see a question here. So we usually weight based on one variable. Well, no, generally, you can use one variable, but it's very rare that we use only one variable. Typically, we use several variables. Like I said earlier, in some of our large national surveys, we use up to between 13 to 20 variables when we are weighing the data. Because we want our population to be like the parent population on all those characteristics.
should you do your weighting for sample size when using data from DHS, or do you do your weighting when you have your results?
When you use data sets like DHS, somebody has already done those weights for you already, right? So when you use publicly available data sets like DHS or GYTS or GAT, there's a variable called final weight. A statistician sat down and did all of these things we're talking about for you. But the point of this lecture is to say, when you are collecting your own data and you have to create the weight yourself, how do you go about this? So if you're using data sets like DHS, somebody has already suffered and done all that work for you. But you also have to know how to do these things yourself. So that is the focus of this lecture is not on weights that have been created already. It's about how do you create weights yourself.
You collected data online, social media in brackets. They self-administered. They made their choices on who to vote for. You know their age group, but is similar to those on real voters register. Can you weigh by age group? Note you don't have real election data by age group.
No, it's not really election data you're looking for. You are looking for data on the census. You're not waiting on the outcomes. You're waiting on the demographic characteristics, right? So if I go to a population if I go to a population that is predominantly, let's say I did a telephone survey or a web survey, and I find that most of them say A is the answer, all right? And then I'm like, but to what extent is the answer truly A in the overall population when I know that this population is mostly a young population? So the question I'm asking is, if this population were to be like the general population, will the answer of A still be 40%? That's the question I have in mind. Then I'm like, okay, how then do I force this population to be like the overall population so I can know the true answer of what is the percentage of A? Well, the answer is I weight the data on age. So I go to my population, my census, and say, what's the distribution of age in the general population? So I can use that to force this sample to look like the parent population.
How does the weighting of socio-demographic variables you have described differ from weighting when equal number of respondents are selected using cluster sampling?
So there are two types of weights. As mentioned, two types of weights. One is design weight. So how do you understand this? Think of weights as very simple, right? You can need weights because you caused the problem, or you can need weights because the respondent caused the problem. In a survey, there are only two sides: the person giving the survey and the person answering the survey. These are the only two sides that exist in the survey. If I caused the problem, in quotes, in how I designed the survey, that is called design weight, because that has to do with the design of the study, right? So let's say I oversampled from one population. Well, oversampling means that people who I oversampled have a higher likelihood of being selected. So suddenly, not everybody has the same probability of selection. There's a bias there already. But that bias was injected intentionally by me because I knew I was going to correct it later using weights. Today's focus, we are not talking so much about design weights, just because we've talked about them extensively last time. Now, that's a different issue. Non-response weight is when the problem is not from me, but from my respondent. My respondent chose not to answer, right? And because of the fact that some groups responded differently, the response rates were different, I now have non-response, differences in non-response patterns, let's say between old people and, younger people. Let's say I gave a web survey, right? And it's mostly young people that are online taking my survey. If I now look at the characteristics of my population, I will see that most of them are young. That means that just because of them, that had nothing to do with me. The older people, for whatever reason, maybe they were not available or they didn't have access to it, did not participate. They did not respond. And so we have to create non-response weight. So those are the two types of weight. Either the problem came from me, which is design weight, or the problem came from the participant, which is non-response weight. And that's why when you use data sets like DHS, you will have a variable called final weight. The final weight is simply the design weight times the non-response weight. We combine those two weights together to give us the final weight, which you then use. So when you take a data set that is publicly available and you just analyze it, these are the decisions and all the work that has been done in the background that you're not even aware of. But when you, the whole point of this is so that you can be at least familiar with these things. So you can, if you have to do a national survey yourself, at least you know that, okay, I know there's something called design weights I have to worry about. And I also know that there's something called non-response weight. And so it's just to give some basic education on this topic so that you are at the very least aware of them. Any other question?
Yes, can inclusion and exclusion criteria solve this weight issue?
No. Inclusion criteria, you're just saying that, let's say I say my survey is people who are aged 18 years or older. Sure, I've defined that inclusion criteria already. But I now launch this survey to the people 18 years or older. Now, after I launch it, I still have problems because some people refuse to answer or the response rates were different. I still have the same problem. So inclusion criteria does not solve the issue. There's almost no study that doesn't have an inclusion criteria, but we still have to weight the data. So that, of course, it's helpful to have inclusion criteria, but the issue of weights is, it's almost a separate issue entirely.
Can one weight the data reference to an initially collected and published sample data?
You can use I'm trying to understand that question. Can you repeat the question again? I just want to make sure I'm answering the person, valid question.
Okay. Can one weigh data, I think with reference to an initially collected and published sample data?
Yeah, you can weight data that has already been collected before, which is the second part of the lecture that we're supposed to move into, so you can see how all of this applies in real context.
How does the weighting to account for socio-demographic characteristics you just described differ from the weighting on the Chi-Squares platform when equal number of respondents are selected using cluster sampling?
We've answered that question before. How come we are reading the question twice too?
No, it's not exactly the same, Dr. Agaku.
Okay.
Yeah. So basically we weight based on one variable. If yes, how do we select this one variable?
We weigh on several variables. We have answered that before. It's very rare that you weigh on only one variable. If you are weighing on only one variable, you're otherwise saying that your population differs from the parent population only on that one variable. That's what you're saying. That is highly, if the population differs by gender, they will most likely differ by age and race and income level too, right? Because if most of your participants are older, where older people have more money than you, that means that they will most likely also differ by income and also differ by other characteristics. So don't just look for one variable. Look for many variables and test to compare between the sample population and the target population.
Okay, that was the last question. Thank you. You answered.
All right, great. So let's jump in now and look at the case study we're talking about. So this is our case study. So no, that's not a case. Let me see. Where is this? So like I said, this is we got our data from here. Let me pull up where is this? So I'm trying to look for the results from the unweighted. So we can. Let me just pull it up directly. Oops. Can you see my PDF?
24.com.
Yes.
Yes, we can see it.
All right, great. So remember the story. Let's tie the story together. We got this data from News 24, right? And like I said, this is internet survey. That they're not the research company, they're just a media company. But they just put surveys and once in a while say, hey, do you want to answer this question on smoking, right? That's how we got data. So as you can imagine, the data were not representative. When they gave us the data, they also gave us this report. And so to them, this was their published findings that they thought were very interesting. And so for us, the appeal was that, wow, this is a large number of people. They had 18,907 people. So we're quite interested in that. Let me see other questions here. Oh, okay, sorry. You guys have so many AI assistants. All right, now when we start looking at the population here, you start seeing some hints of, okay, like when you look at race, for example, for context, this is South Africa, right? When you look at race, the percentage of white, this is green. 50% of the population is in this sample is white. Who sees the problem with that? Lungile, can you see a problem with that since you're a resident South African expert?
Sorry, I can't see clearly.
Okay. Can you see this?
I see.
We're looking at this population group here, and we're looking at this. This is by race. So this population, 50% of it is white. So I was asking you as a resident South African expert whether you saw something wrong with that.
Oh, yes, definitely. We only have maybe what? 70% of the people in SA are Black. So it can't be 50%.
Yeah. So the racial distribution of whites in South Africa maybe is around 10%, I believe.
Yeah.
But you see here in this sample, it is 50%. 50% and 10% are very different. So this is the first time that you have a problem, right? And then when you look at other demographics, look at income and all of that, you might also see problems, right? And then that is also translated into the outcomes of a study too. So if you look at, let's scroll down a bit to look at. So the first thing you do is don't just pick a data set and just say, oh, I want to dive into it and start analyzing and publishing. No. The moral of the story is that when you get a data set, take your time to really explore the data set and understand it first. That's it. So if you did not get anything from this class, it should be that don't just be in a rush to analyze data. Understand the data set first and understand whether the data is fit for use, right? So here we're looking at the data and we're like, okay, based on this data set, what is the prevalence of smoking? So you can see that according to this data set, almost 50% of South Africa smokes currently. Either they smoke rarely or regularly. That doesn't make any sense. Like prevalence of 50%, that's Greece. The only country in the world where you have such a high prevalence rate is country like Greece, right? So you can see the danger of you just grabbing this data and going to publish with it and saying, oh, the prevalence of smoking in South Africa is 50%. Everybody's going to look at you, you're crazy. Like either you're crazy or you are completely like dull. There is no way in the world that smoking prevalence in South Africa is 50%. And it is 50% because of the sample. The sample is not representative. Now, if you are going, let's go back to the original point we made, that your intent should determine the analysis or your interpretation of the data. If you said 50% of people in this sample were smokers, nobody has a problem with that. We only have a problem when you now start saying 50% of South Africans are smokers. Then we'll start scratching our head and saying that makes no sense. That is actually categorically false. Yeah, that's fake news. So that's the point I'm just trying to reinforce, right? It is all about your intent. That the methodology and how you frame results must also follow along with your intent. You have to know when to say 50% of the sample versus 50% of South Africans. Those are very two different statements. Now, in this case, our intention was we're not necessarily interested in this sample because we do research from a regulatory perspective, from policy perspective, right? We're always interested in results that are generalizable. Now, our intent as researchers in this case was to create generalizable knowledge. So the question was, we came into this data late. They've already collected the data, but we need the data because it has a lot of information we need, right? We want to make this data representative, at least to some extent. So the only decision was to weight the data. So I'm just giving you some historical perspective so that you can see how these decisions are made and how they work. So now for context, this is the study we ended up publishing from the study. Let me show you that. And I'll now walk you through how we went through the process of the decision, right? So look at the topic here, associations between electronic cigarette use and quitting behaviors among South African adult smokers. So see how we frame this here, right? Among South African adult smokers. The framing suggests that we are now talking about not just the sample, but smokers in South Africa in general, right? So this was a study published in the BMJ Tobacco Control. Now let's take a little bit of time to look at the methods. So you can now see how we reported the methods, how we reported the limitations as well, and then we can go back a little bit to the methodology. Again, the goal is to guide you through, through this historical perspective so that when you're in that kind of context, you know, okay, what should we be doing or what should we not be doing? So let's look at some of the quick look at the analysis here. Let's go to the analysis here. But let's just focus on this part here. Let me highlight it here. Oh man, okay, one more try. All right, so that's what we're interested in here. So it says calibration weight were developed using raking, which is iterative proportional fitting, with the South African census estimate serving as a reference population. What does that mean? It means that we took the South African population and we used the reports or the percentages from the South African census as the weighting factor. So remember, we have established that you cannot weight if you don't have external data you're waiting on, right? You must have data, right? And so in this case, we used data from that population from the census as our guide. Let me pull that data so we can see in real time what we're talking about. Give me a second if I can find this, okay. So this is the Lungile, seems you're the one that put this report, this data together. All right. So this is the column here. This is the variables we had from Health 24. This is the data set, Health 24. You can see the variables age, employment, race, gender, education, marital status, and a whole bunch of others, right? These are the percentages from the data set. But more importantly, this is what we're interested in. This column, this came from the census, Statistics South Africa. So the Statistics South Africa is saying, this are the percentage of the different groups, right? But we're interested in unemployed. You must have these numbers and they must add up to 100%, in total, right? The total must add up to 100 for each of the characteristics. So you're not making these numbers up. So this is a very important column. This is the column from the census or from wherever Now, it's not always, sometimes it's hard to get data from one source. You might have to go and look for data, estimates from different sources. I just weighted a national survey recently where I had to get estimates from at least 6 or 7 different sources, right? Because I couldn't find everything in one place. So it's not as if you just have everything sitting for you nicely in one place. You might have to go and look for it, but you have to make sure that it's representative data at the national level. Let me see. There are some comments I want to make sure. Alrighty. So this is the first thing you need. You need to know what we call this population marginals. It's just a fancy term to say what is the percentage for each of those groups in the population you are referring to, or that is the reference population. So you get those numbers and they must add up to 100%. So you get all of them, and that's what we're saying in that sentence here. When we'll go back here. Calibration weights were developed using Rakin with the South African census estimate serving as a reference population. Descriptive analysis were performed using weighted percentages. So the whole point of weighting now is to make sure that the results we get, so remember I showed you the difference between when you weight the data and when you ignore weighting. So in this case, we weighted the data with the weights we just created. So we calculated weighted percentages and bootstrapped 95% confidence intervals. Prevalence ratios were calculated with Poisson regression model. Okay, that's not really important for the okay, I think that's as far as our weight is concerned. Let's just stop that there for now, and let's go back to the issue of weight. The question says, in case of Nigeria, where we have the global census of 2006 and the projected population, I want to use the 2006 census data or the current estimated data. The population doesn't change that dramatically between 2006 and 2009. So use whichever one is closest to your data. So you might be analyzing the data today, but the data may have been collected in 2006. So again, there's no rule of thumb. Just use whichever data is closest to whatever data you are using. The sample data and the parent population must be similar, remember? So if the data were collected in 2001, well, it would be helpful to go back to 2001 and look for census data from that time so that the two are like apples and apples, not apples and oranges. I hope that answers your question. Now, I want to now go back to the reviewers, because we had a lot of, we had just to see, again, how we communicate these issues with reviewers as part of a scientific process so that you have a full spectrum of what goes on. So this is our response to reviewers in that paper. So I want to give you a highlight of some of the issues that were raised during the peer review process and how we responded to them. You can use projected data. Projected data is based on actual data, just project based on what we have. We say, based on what we have, this is what we expect tomorrow. So if you have projected data, you can use that as well. If you have actual data, even better. So let's look at some of the reviewer comments. I'm not going to go through all of the comments, but by the way, this is always how you should structure your response to reviewers. You should group them. This is completely off topic, by the way, in case you did not notice. Group them by whose comments those are. So editor's comments, reviewer 1, and then you say reviewer number 1, comment number 1, reviewer number 1, comment number 2, and for each comment, you should provide your response. It should be very clear so that when they're reading it, it's obvious to them. As a journal editor, this is how I like when authors submit their responses back to me. It's easier for me to read it then and make a decision. But anyway, this is not a class on peer review. Let's go back to the topic. You're not weighting the data yourself. The Chisquares platform does everything for you. The goal of this class is not to show you how to do the mechanics of weighting yourself manually. It is just so you understand what's going on in the background, and you can be intelligent about the issue as well. So don't worry about weighting this thing yourself. Well, I'm going to show you how you can do it on the platform, but you got to understand the theory first. Alrighty. So, so this is reviewer number 1, comment number 2. Lungi, can you confirm you can see this Word document?
Yes, sir.
Okay, great. So review number 1, comment number 2. It says, why did you weight the data? I can only accept your decision to weight the data once I have been convinced that you are justified in doing so. To do this, submit a comparison of your sample, which is your data, and the population, which is the census data, for each of the variables that you use for your weights. This should be in table form. This will show whether you were justified in weighting the data or not. In terms of race and gender, income, etc. What groups did you undersample? What groups did you oversample? And he goes on. Because the study was based on an online survey, I presume that it did not have an experimental design that allows you to reweight the data in a way that makes it nationally representative. I know you acknowledge that the data may still not be fully representative of the South African adult population, your limitations, but then why did you wait? It is okay if the data are not nationally representative. They don't need to be. This goes back to the issue of your intent. But again, our intent was to create generalizable knowledge. If it turns out that your sample should not have been weighted, then we do the analysis on the unweighted data and frame your conclusions in terms of the sample only. This is a very good point, right? You can't use unweighted analysis and still be talking about the nation overall. Your analysis and your framing has to follow the kind of analysis you did. All right, so this is our response. We have provided the requested data points below. In order of appearance of the columns, we have compared results for 1, the unweighted data set, 2, the weighted data set, 3, weighted data from the 2017 SASAS, which is a nationally representative household survey of South African adults, and 4, mid-year census projections from Statistics South Africa. So here, this is what we've done, right? The first column is the data that were not weighted. This is what we have. And the second one is the one we weighted. After we weighted the data, we calculated the same thing. This is what is in the second column. Column 3 is from another national survey that is well respected to be nationally representative. And column 4 is from the census. So when you look at gender, for example, the unweighted data shows that 50.2% are male. Our weighted sample shows that to be 47.7%, which is almost very, very similar to what you get from national estimates. Let's go to something else, like let's look at race ethnicity, since it's more dramatic. For race ethnicity, the unweighted sample shows that only 27.35% of the sample were Black. When we weighted the data, that was 68.83. It is still lower than what you have in the national estimate, but at least it's much, much closer. Again, remember that weighting will not automatically solve all the problem, but it at least reduces the problem. For whites, for example, the sample, unweighted samples showed that 50.4% were white, but after we weighted the data, that percentage dropped to 19.8. Again, it's still higher than what we see nationally, but at least greatly improves the distribution. So now, to respond to the reviewer's question on why we weighted, 1 is to increase the relevance of the research for policy. At a time when South Africa is poised to pass several tobacco control regulations, including e-cigarette taxation by the Treasury and the law to deem e-cigarettes as tobacco products, data are surely needed. Weighting the data so it resembles the general population better benefits public health, as opposed to unweighted analysis whose distribution looks nothing like South African population, especially the racial distribution. It is evident that weighting did not fully correct the sampling error, but at the very least, it minimizes this bias. And then we're saying weighting, including of web-based surveys, is a standard procedure, and this is more of just saying this is standard procedure. And then we also provide more context. So the reviewer had earlier said that because the study was based on an online survey, I presume that it did not have an experimental design that allows you to reweight the data in a way that makes it nationally representative. Our response to that is, yes, the reviewer is correct that most probability-based samples require a different approach to weighting. In such cases, base weights are simply calculated as the inverse of the selection probabilities, and the products of the conditional probabilities at all stages computed equals the weight. However, there are several other weighting protocols besides base weight or design weight. For example, in the world of journalism, where we weight web surveys, we use other things like raking. And so I'm explaining here that in our study, we use a procedure known as raking to generate this weight. This accounts for non-coverage or non-response bias, but does not require individual selection probabilities. All that is required is the distributions of a sample population as well as the target population. And so we've said, all right, here is the code. Science is all about reproducibility. So we'll say, okay, here is the source of population marginals. This is where we got the data for the national distribution. And here is our code on how we implement the weighting algorithm. I'll provide the code here. And this is how the code was calculated. And, well, okay, if you want to recreate the weights yourself, well, knock yourself out. And so that is how, of course, that's how you want to respond to reviewers. Obviously, the paper was published because our responses were quite comprehensive and robust. Any questions on that comment and response? So I just want to give you context as to the kind of negotiations that you also have to engage with journals before you publish. And again, take note that even after we weighted the data, we still had, it wasn't as if we solved the problem completely, because the distribution of whites was still much larger than what we had in the nation. And that's what we also included in our limitations here. We said that some limitations exist to this study. Let's see. The final one here. We said, finally, despite waiting to reduce non-coverage and non-response biases, this data may still not be fully representative of a South African adult population because adjustments were made for only a few variables for which information was available in the data set. Remember, we didn't adjust for a whole lot of variables. We adjusted only for age, employment, race, gender, education, marital status. Yeah, we only adjusted for 6 variables. And so that is not like a whole lot of variables. Like I said earlier, remember, in most large surveys, we typically will account for up to 20 variables. So for those of you who are asking me, is it enough to weigh on only one variable? That's your answer, right? No, it's not enough. In general, you typically want to adjust for as many demographic variables as possible, because that just improves the representativeness of the study. And again, our intent was to create generalizable knowledge because we are policy researchers, like we're a policy think tank. So it is of zero interest to us to analyze data among a sample we don't even know about. No, we care about national estimates or national data, and that's why we had to weigh the data so that we could make inferences that were at least close to national representativeness. I see some hands raised up. Yes, let's see your questions. Yeah, any questions? Okay, now, if there are no questions, I would like to show you quickly how this is done on the Chisquares platform. We already did. Look, your hand is up.
No, sorry, that was a mistake.
Okay, all righty. So let me quickly, we did this the last time. I'm not sure how beneficial this will be again, but for those of you who were not there the last time, I will just go ahead and show you how this is done on the Chisquares platform. So your survey, when you collect your data, your survey must first of all be closed before you can weight the data, because weighting means that you are done with the data. Your data collection is closed. So it's closed. So that means you have to finish your survey before you weigh the data. Remember that nobody in a data set can have a weight of 0, and nobody in the data set can have a missing weight either. If the survey were not ended and I did weighting today, and then some people came tomorrow and answered the questionnaire, because I already weighted the data, that means that variable, they are going to have missing values. So the platform will not even allow you to generate weight for a data set that is still ongoing as far as data collection. So that is a validation that is built into the data, into the platform. So you've done your survey. Oops, sorry. So you've done your survey, you've closed the data. Now you want to weight the data. So let's look at how that works. So you go to the data the survey you are trying to weigh. Let's do a quick. All right, this is it here. It's closed. So I have this data set. This is just a mock example. But if you've collected data, this is the exact same process you would go through. So like I was saying earlier, there are validations built into the system so that the platform will prevent you from trying to weigh data if data collection is still ongoing. Sorry, what's happening to my network here? Already. So you come here under data access and insights, that button there, and you see there's a button that says weight data. Can we import data into software for weighing? Yeah, we're going to work. We've not released that yet, but we can. That's one of the things we're trying to incorporate. But for now, you can only weigh data that you've collected on the platform. But we're going to fix that very soon. So again, let me repeat the journey. You've already collected data on questionnaire design. That's where most of you are familiar. But to where you come to manage collected data, you come to data access and insights. This is where you also download your data set and everything. But now we're not interested in downloading the data. We're interested in weighting the data. So you click on weight data. And here, if you have done weights before, you have a history of those weights, right? You can create new weights. Now, remember I said that if you weight data and you come back tomorrow and you wanted to, for example, edit those weights with a different parameter, you can always come back here and this buttons to do a whole bunch of things. But anyway, that's not the focus of today. Let's go about how do you create weights. You come here. If you've never done any weights, this will obviously be empty. There'll be no history. So you click on this button that says new calibration weights. And next, you select the variables that you wish to use in creating the weights, right? And so drop down here to display all the variables in your data set. You now select the ones that you wish to use. Let's say you select that one, and I select this one, and I select, this is just a mock demo, so I'm just creating just random things here. So I've selected 4 variables that I wish to weigh on here. And you can see they're all displayed at the bottom here, right? Now, the next step is for me to, okay. I was thinking that data sets are weighted after data analysis. No, you don't weight data sets after analysis. The whole point is to use the weights in the analysis. So you get the weights and then you incorporate them in your analysis. So that's the whole point, Toyosi. So weighting must occur. If you weight the data after your analysis, the question is, what's the point of creating weight? The point of creating weight is to incorporate them into your analysis. All right, so we've selected the variables here. And now we have to provide the percentages, right? So you see that each here, you have, for example, this variable, whatever variable it is, we have to provide the value. These are the categories in the data set, yes and no. So if this variable had missing values, the platform will automatically reassign those missing values to yes or no. So all of that process has been completely done for you. You don't have to worry about that. You now have to now put the percentages in the target population. Let's say in whatever variable this is, let's say the population is 40%, and for the second category is 50%. Now, this has to add up to 100. Otherwise, you get an error. The total percentages must add up to 100%, right? So the system will not allow you to progress without that. So let's say I change this to 60. Now I can say I'm done with this variable. Then the next variable, this is marital status. I have to provide the percentages, not just from my memory. I have to look at the census. What the census says, let's say 30% are separated, and let's say 10% are widowed. You can't have a variable that is 0. The platform, how can it be 0? It doesn't make any sense. So it has to be a value that is above 0. Let's say 23% are never been married, and 12% are this, and the current percentage is displayed at the bottom for you, and 10% at this, and let's say 15% at this. Now that's up to 100. Can say I'm done with this variable. If it's a continuous variable, that you can only weight on categorical variables. So if it's a continuous variable you selected, the platform will say, okay, how many categories do you want to split that variable into? So like I can say, I want 3 categories, right? And then it's going to say, okay, from 2010 to where do you want to define the end of the first category? Let's say 2000 to 2015. And then from the last cutoff, which is from here to like, what's the next value? Next value I might say is 2020. And then from the last cutoff, which is this, to this. And then I will provide the different percentages in the population, right? But let's say, for sake of just simplicity, let's say I just want to wait on this 2 variables. Let me delete this for simplicity so that we can just use this 2. Confirm removal. So we have 2 variables here that we want to wait on. So we've selected them, we've assigned the population distributions, and now we just generate weights. So the platform has now created a weight for us. And you look at the history, this is 531. So this is the weight variable here. Up top here, these are the 2 variables we use for the weighting. This is the name of the weight variable, so that when you download your data set, it will have the weight variable in it automatically. You can also go ahead and do a whole bunch of other things, like you can delete the weight, you can compute benchmark, you can look at the summary of the weights. So this is telling me that the weights range from, this is the new weight we created, this is the minimum value, this is the maximum value, this is the median. So this is the 5-number summary for the weight. So this, like, you will not understand how critical this feature on this platform is. It's one of those things that you really must have gone through some serious statistical suffering to understand how much of just a lifesaver this feature is, but it really, really saves your life when you're doing that kind of national surveys and you have to wait, because it really, really simplifies the process in a way that anybody really can generate weights for themselves and use them in their study. I see there are a whole bunch of comments, so let me stop now and take those questions. So now you created a weight, right? Now, when you now want to analyze your data, look at the manual we said you have to set the data to survey weight, right? Then those are the exact same weights you now use in your analysis. So there are 2 parts of the coin, creating the weight and then using the weight. So we've created a weight. So if you download this data set, you'll have a new variable called var12. You can change the name of a variable if you want. You can say, okay, I don't want to call it that var12. I want to call it something I can remember, like my new weight, so I don't forget. And you can rename the weight, right? And so that when you are now analyzing the data in your data set, you go to my new weight and you can use that variable. But the use of a weight will become similar to what we discussed earlier. I think we showed you how to do, let me see if I can. The manual, I can't figure out where the manual is now, but in the manual, you have how to account for weights. But it's exactly the same process for incorporating those weights as you have in the manual. So yes, at that point, it doesn't define the exact same thing. Any other questions? Let's see.
No questions. I was thinking that.
Sorry, go ahead.
I was thinking that the data sets are weighted after data analysis. Am I wrong?
You are thinking that what is weighted after data analysis?
The data set.
No.
Is only weighted after analysis. Mm-hmm.
No, you don't. The whole point of weighting is to incorporate the weight in your analysis. If that makes sense.
Can we sorry.
Go ahead, yes.
Can we import data into the software for weighting?
Yeah, you will surely be able to do that, but for now, no. but we're working on that.
Yeah, that's it for now,
Okay.
question-wise. I can't see hands today. Let me try to check.
I think we should have another session that just focuses on using the weights on the platform, how to use it. I think today's class was focused a little bit more on the theory. And I think that's important too, right? I think you have to know the theory, at least a little bit of it, to understand what's going on. And so we could have a different session that just focuses on, okay, now this is just hands-on demo. How do you actually use weights on the platform? I think that would be helpful. And I see some people agree too. So we could choose to have next week. We're planning on having next week we're planning to have a session on causal inferences. Longe, do you want us to still go ahead with that, or should we just do the weights instead?
Are we then going to do the causal inferences after, the week after?
Yeah, no, well, or we can just ignore causal inferences altogether.
I see you. Okay, those who have their hands up, I think Kinsukulu.
Okay. So we'll keep causal inferences next week then, and then we'll see if we have.
Oops. Okay.
But by the way, causal inference is just going to be a whole bunch of theory. There's no hands-on or demo next week. We're just talking about what in the world is causal inferences. And so
can we combine the two?
Yeah, we'll try, but I can't promise. It's better to have one session where we understand it completely than to try to deal with two topics where we end up being extremely confused.
We can do the
try to accommodate both, but we'll just play it by ear. And I understand that this weight issues, the weighting is sometimes a bit abstract. And I try to make it as simple as possible. But I really hope that you can at least understand have an intuition for what weighting is and why we sometimes have to deal with weight. It's all about intent. Like, what is your intent? Do you intend to create generalizable knowledge? So you are the one who is in driver's seat. But should you choose to go down this route of generalizability, then you have to make sure you do it well. And that's where weights come in. And I think that what we've also addressed today is one half of I assume that many people were in this last session where we focused on design weights, right? But that may not be a true assumption. So one of the other things we need to do is we need to bring those two things together. You have design weights and you have non-response weights. How do we then marry them together to create a final weight so that you don't go away with half knowledge? So maybe we can also have the next session or whichever session we are focusing on hands-on, we could use that to build on the issue of design weights as well, and have so that we can make your knowledge of weights more holistic, because half knowledge is very dangerous.
Nahal Hassan, you have a question? You may unmute.
No, I don't have.
Oh, okay, your hand is up. Okay.
Okay.
Who else?
Sorry.
Taiwo.
Hello, good evening.
Hello.
Okay, just a quick one. You said something about confounding the other time, and just a little bit of throwing of light into it from your side. My own mind before was there are two main instances that can cause a variable to be okay, to use for confounding with that variable. Number one, if maybe it is significant in your analysis, then you can use it to test for confounding. Or even though it's not significant, if it's been reported as an independent variable that can influence the outcome, then you can also use it for confounding. But from the way you said it the other time, it looks like you said we can use any variable to test for confounding. Just a little bit of clarification on that. Thank you.
Oh, you're welcome. Confounding has to be based on a solid theoretical knowledge. So what does that mean? It means that you should have good knowledge. So it's not just any variable that you can use, right? So one of the things I really discourage researchers from doing is things like forward selection or backward selection, where it's like you're just throwing variables into a computer and saying, oh, whatever the computer brings out, I'm going to use, right? That is not appropriate, because research should be a very theoretical, or at least theory-driven. So there are three requirements that have to be met for a variable to be called a confounder. Number one, it has to be independently associated with the outcome. Number two, it has to be independently associated with the predictor. And number three, it must not lie on the causal pathway. So you should have the habit of drawing DAGs. DAGs are directed acyclic graphs. And I think we should have a session on DAGs because it is extremely important in the practice of epidemiology. DAGs will help you to conceptualize whether or not a variable is a confounder. Now, I must also say that the fact that a variable A was a confounder in Mr. A's study doesn't mean that it's going to be a confounder in my study, because no two studies are the same. That is, again, why it is extremely important for selection of variables to be based on solid knowledge of theory and the understanding of the disease context or whatever the outcome is. I hope that makes sense.
Yes, it does. It does. Thank you. It does.
Okay. So when we are in our session on DAGs or directed acyclic graphs, we'll focus more on how does that work in practice, like beyond the theory, right? In practice, how does this work, right? So that we're not just doing things like robots or machines. Like that's some theory. And so we're going to focus on that when we talk about DAGs.
Blessing.
Yeah, thank you very much for the session so far. The question I have is not on what we talked about today, but it's just something that I have had a problem with while trying to use things like Qualtrics and things like that. When you're dealing with qualitative analysis, right, and you have to, I'm sure you've used like Qualtrics before, and you have to basically categorize your qualitative data into like keywords and things like that. Does Chisquares have like an AI integration in which you just need to like put in it has your data and everything, so it generates like keywords that can group your responses into like the required format, or does it have to be manual? I don't know if you get my question.
I do, yeah. No, everything is done for you automatically on the Chisquares platform. So if your data for all qualitative data, the platform does two kinds of analysis for you, which is automatically reported in the analysis report. Number one, it does the thematic analysis. Thematic analysis is a qualitative approach where we identify themes. Themes are derived from code. So the platform does all of that. And so you have, thematic groupings of the responses. Second, the platform also does a word cloud analysis. Word cloud analysis is a bit different from the thematic analysis because it's looking at the preponderance of words that were used and using that to create a cloud, so to speak. So you can look at what words were the most frequently used and to what extent. So depending on, so you have a choice to go with the thematic analysis, but both are presented for you automatically, so you don't have to manually do it. I mean, we are very big on automation, so anything that can be automated, we do automate it, and that is something that can easily be automated. So we do automate it.
All right, thank you.
You're welcome.
Abdul.
Thank you very much, Professor Isaac. Thank you very much. Now, my question is, where you did your reporting on that cigarette issue, respond to the reviewers. Is that from the code book, or it is independent of it's after the code book? Then, secondly, again, I like the cigarette stuff, but the issue is that, for example, we have different surveys that is done in Nigeria by the Bureau of Statistics and other surveys. For example, when they talk about data on out of school girls, I constantly find it difficult to accept whether those data is correct. Can it be standardized, or can it be weighted so that we can be able to see how it is done based on the Chi-Square platform? Thank you very much.
Thanks. So the reports to reviewers, that is just it's not based on the code book. That is just that was just we and the other co-authors just responding to the editor and the reviewer. So it's just based on, we're just responding to their questions. And the questions may be different from one reviewer to the other, right? So it's just a direct response to them. As an editor-in-chief myself, I really appreciate responses that are very thoughtful and that are very in-depth. For me, I also think of response to journal reviewers as also an opportunity to clarify, but also to educate. Because sometimes the concept of peer review is a misnomer, because the people reviewing sometimes are not your peers. Sometimes there are people who are very early in their career. So, and of course, sometimes there are people who are quite experienced too, right? Much more experienced than you. But my point is that sometimes that is not necessarily your peers who are reviewing. So for me as an editor and as somebody who loves mentoring, I always provide responses in such depth that it clarifies, but also educates. So that's why my responses tend to be more nuanced than that might be necessary. But it's a good thing, because once you respond for the first time, you're not going to respond again. The paper is almost guaranteed to be accepted after that round of revisions. The second question about weighting, and again, this is why we need to have sessions like this, because you need to understand how these things work and sometimes challenge the process and say, I don't think this was, because the people who are doing the weighting are people just like you. For all you care, they might know less about weighting than you do. Now, if you have no knowledge of a topic whatsoever, you will just accept whatever is given to you as, well, the word of God. If you understand these processes, however, you can look at it and say, no, I don't think this was done correctly. And there are many instances where I have used data set. I'm like, no, there's a mistake with this weighting. And I reach out to the survey, administrators, and like, this doesn't look right. You have a missing value for weight. It's impossible to have weights that are missing. But you can only make those kinds of feedback if you are well-informed. So I think a well-informed academic community is a great thing, because it improves the process for everybody. You challenge things, and if you don't like it, you can reweight the data yourself. Although the problem is that if you reweight the data yourself, it makes it impossible to compare with studies, because if other people use data sets with the weights that were supplied, and then I reweighted the data myself, that creates a bit of a difference. So, and that's why in your methodology, you have to be very clear on what was done. Now, there are some instances where I have used data and recalibrated the weights myself, even though the weights came with that survey, because there are certain statistical procedures that you might be doing that also generate weights themselves. So take, for example, I'm trying to do inverse proportionality weighting, which is a statistical process to adjust for missing values. Now, IPW will generate a weight of itself separate from the weights that came in the data set. So in that case, the final weight will be the original final weight times the IPW weight, right? So now I have a new weight altogether. So that is why you also have to explain your methodology in great detail. But I think overall, it's just making sure that we're very well informed about the process of weights and also just challenging, right? You can write today survey board and say, can you provide more details about the methodology? Like, how did you weight this thing? What variables were used? And I think that benefits everybody because it improves our surveillance systems and our surveys and data collection systems and just makes us better overall. So I hope that answered your question. Okay, great. Any other questions?
Joy?
Okay, thank you very much for this class. I'm so impressed and really quite interesting. And just like Abdul, I was also here wondering about how international communities come.
You are sounding, sorry, you're sounding very faint. I'm not sure whether you're wearing headphones.
Okay, yeah, I'm wearing a headphone. Okay.
Okay, you might want to remove them, or maybe you went the other way around, the wrong way.
Okay, can you hear me now?
Aha, yes. What did you do? Did you remove them?
Yes, I had to. I'm
Okay,
actually
great.
waiting for a flight.
Okay.
So I was also wondering, like Abdul, how we have international communities, because I've been coming across several information. They say 40% of Nigerians live in abject poverty, and there are no variables, or I don't know how they are measured or the weights assigned to it. But like you said, it's always proper to question. But now the challenge I have is that how do you question an authority that the country itself has, signed itself to, like everything they say is right? And when you're talking and when for international publications and you don't have mention of, say, UN Center for Housing and Sustainable Cities, you don't have the World Bank mentioned, it's like you haven't really covered all information. So that I find quite challenging. But my second question is can we have this, how to use chi-squares for quantitative just and type it and have those information. I think it will also help us in also learning beyond the class so that a lot of people can also be aware of chi-squares. So for me, it's just a simple request if it's possible to have how to use chi-squares online on YouTube, and then we can learn faster also how to use the platform from there.
Okay.
Thank you.
Definitely. Thank you very much. So your first point about like estimates that come out and you're not sure, I think you can ask. We need to do a better job of also asking, and this is what you call more of a democratic scientific community, right? We need to start holding our scientific leaders' feet to the fire. If you put out an estimate or a report, you have to provide an appendix that discusses the methodology. You can't just put out results without methodology for how those results were derived. So that's something that we need to be doing. And if we see that is not done, we can write to them, right? Say, hey, with reference to the reports, this official government report, I see that this was not addressed, right? There are many ways you can address that. You can write to them, and you can write an editorial, right? This is the medium you have. An editorial is a piece of communication addressed to issues like that. You can say, okay, scientific communication, are we capturing things right? And that could also be a gap in knowledge where you can explore in your research. Like, is the prevalence of abject poverty truly 40% in Nigeria? What could be wrong with the methodology, right? And so you can also request for that same data they used and reanalyze it. And in fact, that could even be your own specialty, like become a methodologist. And so I think there's so many ways you could go around that to addressing it. But I think keeping silent collectively is not the solution. We have to find a way of saying we need methodology. We need to be a more transparent society in terms of how numbers are calculated or generated for our consumption. And yes, on YouTube, we can definitely put up, more videos on how to use a platform on YouTube and other platforms.
Thank you.
Any other questions?
Are we trying to say that reweight of data will always lead to loss of some data?
No. I never said that. I said it will lead to loss of comparability. The data will not be lost, but if I weight data with one particular variable and you weight data with another variable, remember that what weighting is doing, it is creating a pseudo population. A pseudo population simply means a fake population that does not exist in real life. But if all of us are using the same weight, at least we are all creating the same fake population, right? If I use my weight, I create my own fake population. You use your weight, you create your own fake population. Oh, then how are we comparing these two populations, right? So what I was saying is that when you use different weights, you create different pseudo populations or fake populations. And so it makes it hard to compare between apples and apples because you are looking at a completely different pseudo population. So the moral of the story is that when you weight, what you're doing in effect is that you're creating a fake population. Well, we don't call it fake, but we call it pseudo population, but literally it's a fake population you're creating. And so that is why if you create your own weight, you have to provide a methodology so that when people are comparing the studies, they won't be shocked that how come the prevalence changed so much in the two studies? Well, it's because there are two different populations altogether.
Thanks for the lecture. How is this related to propensity matching?
Propensity matching is a way of adjusting for confounding. Confounding is a completely different issue from what we're talking about here. There are three types of biases in epidemiology. We'll talk about confounding, which is the most common kind of bias. We'll talk about selection bias, right? I'll talk about measurement bias. Measurement bias has to do with how things were captured. And so confounding is a bit different. It's an entirely different ball of fish entirely. And propensity score matching is just one way of controlling for confounding bias. There are other ways too, of course. But in the context of what we're talking, this is an entirely different issue. We're talking, in this case, we're talking about issues of generalizability, which is a form of external validity. To what extent do results from our study carry over to a broader population? And that is the issue we're talking about here. So confounding is a different issue, which you can address with propensity scores.
Sometimes a survey may run along with data that is obtained from empirical research in the laboratory in the hope that information from demographic data can be related to results from the lab. How can this be handled using the Chisquares platform?
So responses from, if you collect data, right? If you collect data from an individual, let's say and this is something we do routinely. This is nothing new. Like we might do, for example, a survey where we have different components. So we have a self-reported module, which is like, okay, what's your smoking and where do you live and how many people live in your household? Those are all self-reported items. But then we also have other indicators, like, for example, your blood sugar and your HbA1c level and so many other indicators. Those are captured in the lab, right? You can also have a scenario where each individual has a unique code that is then transported or matched, whether they are in a self-reported mode or in the laboratory mode, right? And so that makes it easier for you to upload both responses and match them to the same individual. So there are many ways you can do that. So one is for you to assign a key so you can think of it as two different surveys, right? Where you have, okay, survey number one is self-reported responses. So you identify each individual with a unique ID. So you can ask them, well, what's your phone number? Or what you ask them something that's very unique to them. And you ask that you have that same information in the other survey. So you have the same unique key, and then you can then merge the two data sets together with that unique key. So that way the self-reported information and the laboratory information are together merged for the same individual. So the platform allows you to do that in many, many ways. But for me, if I were doing it, it's just easier to use a common key in two different surveys, so that as I'm collecting the lab data and I'm collecting the self-reported data, I have a common key that is unique to each individual, which I can then use later to merge. I hope that the platform also allows you to merge your data, so that's not complicated at all.
Okay. Working on a comparative
Does it
study.
mean? Please go ahead.
Working on a comparative study among adolescents living with HIV and non-infected groups in a state. Question 1, do you recommend weighting for both groups using state census data as the reference population? Question 2, if yes to question 1, which is the most appropriate to use for weighting? National census or state census data? Thank you.
If you're going to weight, then you have to, the sample population and the weighting population must be the same. I can't be collecting data in the states and then I use national data to weight. If it's a state, then I have to use data for that state. The whole idea is to make that sample to look like the target population. In this case, the target population is the state, not the country. So the reference population must be what you want the sample to look like. If you're trying to use national parameters, then that means that you're trying to say this sample should look like the nation. But what you want is the sample to look like the state. So you use the state population data as the population marginals. And I don't recommend weighting. Like weighting should be something you do rarely. It shouldn't be like, just sometimes just, simple is good. So no, I won't recommend you can just use data from that population for your inferences. So the inferences are not extended beyond the study population, which is completely fine too. So remember, it's a question of what is your intent. If the intent is just to refer to that population, then please, just don't worry about weight.
Does it now imply that the variables for each data set in the pseudo population after weighting are all the variables that will be used for data analysis?
That question is a bit convoluted, but I'm going to answer it in how I understand it. So remember that we said that weighting is all about forcing the sample to look like the parent population. The way we force the sample is by taking those weighting variables and making that sample to look like the parent population on those variables. Now, outside those variables, what about another variable that we did not use? Well, that means that the sample will not look like the parent population on those other variables that we did not include. It will only look like the parent population on the variables that we included. That is my understanding of that question. If I missed something, any part of it, I'm happy to clarify further.
Can the platform not generate the values automatically when we choose from census conducted in countries of choice?
No, it cannot do it because that would be bad practice to do so. Like, how do we know your sample? Even if you said your sample is Nigeria, how do we know your sample is of it could be a sample of young adults. It could be a sample of older adults only. It could be a sample of anything. There's no way we will know that because guess what? It is your intent. So in as much as we cannot read your intent and who is in your study population, you're the only one who can supply those parameters. The hallmark of a good engineer, or one of the easiest things that engineers or data scientists fall prey of, is trying to optimize that which should never be optimized. All right. So it's great to be all about efficiency and convenience, but you, as a good engineer, you have to know when optimization must end, and people have to do the manual work. So that ability to say no, that okay, no, this is where you draw the line. This is the parameter that must be done by a human being, is very extremely important, And in this context, those are one of those things that must be supplied by the human being, because we're talking about your intent in this case, and nobody can know that except you. You're the only one who knows where your study population is or the specific ages, and so you're the one who has to supply that value yourself.
what happens with populations that might be illegal in a certain area?
Population that might be illegal? Did I hear you correctly?
Yes, in a certain area.
Legality
this word.
Criminality and the study population have nothing to do with each other. I might be doing a study of undocumented individuals in the country. If that is so, if your study is of just, let's say you're looking at a study of undocumented sex workers, right? Well, then why are you trying to weight the data? Like, what is the population you're trying to weight the data to? In that case, weighting does not even make sense, because the study population is your interest is in that population alone. So you should not even be worrying about weighting, because the inferences for your study do not exceed that special population alone. So anytime you have a special population in your study, that already tells you that you don't need to weight that data. You just have to worry about that sample, because your inferences are just going to be limited to that sample alone. That is why it's called a special population, as opposed to a general population. You only worry about the weighting when you're talking about the general. So opposite of general is special.
When do we use gender and sex, or can the two be used interchangeably?
The two cannot be, they are very different things, and they're not exchangeable at all. Sex is a biological construct. Sex only has two categories, male and female. Of course, you can have, then there's more of a behavioral construct. You could have boys, girls, man, woman, transgender. Those are completely different things entirely. So they're not exchangeable at all. Now, if you have data on both, great, you can ask, but you also have to be aware that it is also very sensitive information, collecting information on gender in some cases. In some cases, you also get a lot of wrong information. People would not, and so in certain neighborhoods, if I'm collecting data in the northern part of Nigeria, for example, I will not necessarily care about, or I will not necessarily feel confident about collecting data on gender, because for one, even if I did, I will expect a lot of misclassification. So in that case, I will just collect data on sex alone. So you have to worry about how much of an issue is there, how acceptable is it? Is it issues of, what quality of data you think you might get if you even ask the question. So before you ask the question, you really want to think about it very carefully and think of the quality of the data you might end up with. And so sometimes it's like, okay, I'm just going to ask you about the sex only. Like, what sex were you at birth, male or female? And that becomes more simple to collect.
It appears that it is not the dataset that is weighted, but rather the results obtained from the dataset. Considering the example you used from South Africa, where we see figures in percentages, is that correct?
So we weight the data set, we generate. So what the Chisquares platform does when we create that weight is that it takes that data set and gives everybody a weight. So we have a new column called the weight column, right? Then when we're doing our analysis, we incorporate that weight in our analysis. So the analysis also become weighted, right? So in a nutshell, we are creating a weight variable in a data set so that we can use it to weigh our analysis. If there's no variable called weight, then like where we can't weight the analysis, we can only use variables that are in our data set. So before we can weight data, we have to first of all create a weight variable, which is what the platform is doing. And then you can then use that weight variable to do your own analysis.
No further question. Any other questions? Okay. In case I'm asked to provide ethical clearance in a study, should I change my study to longitudinal because of the protocol involved to get ethical clearance?
No, the platform, okay, I see. The platform, you can get ethical clearance for both cross-sectional and longitudinal, so you don't need to change anything.
If I'm to ask, what is the difference between gender and sex?
Gender is a behavioral construct. Sex is a biological construct. Sex means that biology means that it is who you are. Biology means it's defined by your chromosomes. So sex is defined by XX and XY chromosomes. If you have XY chromosomes, you are a male. If you have XX, you are a female. So that's what we mean by it's a biological construct. Gender, on the other hand, is a social construct. Social construct means that I get to define my own gender. I can come tomorrow and tell you, hey guys, I am a lady now. And then so that's what we mean by it's a social construct, okay? You get to define it. You get to define it yourself. And if I say I am a lady, and you now call me, I'm sure you've heard people say, oh, you misgendered me. Misgendered me, you say, meaning that you call me gender separate from what I identify. Well, I hope you get a point now, right? So gender is a social construct. There's no limit to the number of genders because they keep growing every day. So genders could be, like male, male and female are strictly, so if you're talking about sex, so don't confuse male and female with men and women. Male and female are categories of sex. Male, female, categories of sex. So don't put sex and then put man and woman. It sounds very confusing because you are assigning categories that are meant for gender, but putting them under the word sex. If you're going to say sex, the only thing that I expect to see under your categories are male and female. If you talk about gender, now there are many categories for gender that are beyond two. Under gender, you can have man, woman, boy, girl, transgender, you can have agender, you can have, there is no limit to the number of genders because it's, and I also remember that another thing you also have to also remember that gender is not also the same thing as one's sexual orientation, right? Sexual orientation is quite different from your gender. So somebody who identifies as a female, and then they say their sexual orientation is, they are straight, or they're, gay, or they are, bisexual, and so on and so forth. So that is an entirely different thing. But bottom line is sex is a biological construct that is defined by your chromosomes, whereas gender is a social construct that is defined by how you feel that morning. And, so that's what we call the social constructs.
How do you discuss weighted variables and how does it affect statements on generalizability of the finding? Okay.
So you define the variables. Essentially, you list the variables that you use for the weighting, for the weighting, and why you selected them. So it could be that you compared the distribution of those variables in your data set versus those in the, in the general population, right? And you found a difference. These are typically demographic variables. And in general, for the weighting, you have to, for you to know what the weighting is, the impact on weighting, you must be able to have a benchmark. So if you look at what we did in I'm no longer sharing my screen. If you look at how we looked at let me go back to my screen quickly. So if you want to talk about the impact on generalizability, you should be able to have a table like this that shows when the data are weighted and when they're unweighted, and the census estimates. This is helpful to be able to know whether your weighting did anything useful or not. So that's how you address that.
Okay, that was the last question.
Okay. This is one of those topics that I feel are just a bit unfamiliar to many people. But I hope you guys left one or two things.
Good, we're learning.
That's great. And some of these things take a lot of repetition. You have to hear them over and over, and also do them. It's not just hearing. You have to try your hands on doing them too. So that's where it becomes solidified.